Hi, fifth graders. Today we are going to kind of summarize everything that we have learned so far about dividing fractions. I know you did that yesterday too, but I really feel like we need another session of it and maybe another one after that. This is a brand new topic. So what you're going to need for today, you're going to need a pencil to write with, and I need you to get your math spiral. Your math spiral. We used that when we did our small group work, and I know it's been a while, but pull that out of your binder, and I want you to open up your math spiral to the next clean page, and at the top write dividing fractions. So just continue right along the next clean page that you have, dividing fractions, and we're going to work through some examples together, look for some patterns, and then I'll have you try a couple on your own where you can pause and press play and all that good stuff. All right, so once you have all of your things, we're ready to roll. Okay, so here's what I'd like you to do. First, make sure you write dividing fractions. The first kind of problem we looked at was a problem like 3 divided by 8. So I want you to write that down. 3 divided by 8. And we saw that we can't just solve this the way we normally would, like a problem like 12 divided by 4, because this isn't going to come out to a nice whole number. Usually we can use multiplication to help us figure out answers, right? Like if I have 12 divided by 3, I could ask myself, well, 3 times what is 12? And then you can get your answer. But when you try to ask yourself 8 times what is 3, that's a little trickier to understand, right? So we used inverses to figure it out. We started with a visual picture, and we saw that we could use the inverse of division, which is multiplication. And if you take 3 and divide it by 8, that's like taking 3 whole and cutting them each up into eighths, and you have 1/8 of one, 1/8 of another, 1/8 of another. So 3 divided by 8 is the same thing as 3 times 1/8. And if you have 3 times 1/8, that would mean 1/8, 1/8, 1/8. That is 3/8. And it might help to look at it like, remember when you multiply by a whole number, you put the 1 underneath it, and 3 times 1 is 3, and 1 times 8 is 8. But either way, using this method of inverses, using multiplication, it works, right? And I didn't just change it to 3 times 8, because 3 times 8 is 24, and 3 divided by 8 is definitely not 24. All right, let's look at another example like that. 5 divided by 7, and we saw that with 5 divided by 7, I could do 5 times 1/7. And again, we drew all the pictures out from this before. I'm not going to make you draw the pictures again, but we saw that this does work. So 5 times 1/7, that means 5/7. And if you think about it, like, and you don't have to write this down, but I'm going to write it over here. When I give you like 15 over 5 like that, what would you tell me that equals? I'm sure you would tell me it equals 3, right? Because this really means 15 divided by 5. That's what that means. So the same thing here, if I'm giving you 5 divided by 7, that means 5 divided by 7. I know it's just strange because the numerator is smaller than the denominator. Sometimes you do have a larger numerator, like 10 divided by 3. And this is another one that I'd want to use the inverses for, because I can see, hey, this does not come out to a nice whole number. I can't multiply 3 by something to get 10, right? So we can change this to 10 times 1/3. And that gives you 10/3, which is the same as 3 and 1/3, right? Okay, so what I want you to kind of notice here involves you having to understand reciprocals. And again, reciprocals, like an example of this, and you don't have to write this, I'm just going to write it up here. The reciprocal of 2/3 would be 3/2. The reciprocal of 4/5 would be 5/4. The reciprocal of 9/10 would be 10/9. So if we had to define what a reciprocal was, we could just say that it's basically the original fraction switched around. So the numerator becomes the denominator, and the denominator becomes the numerator. It's kind of like you're flipping it around. So if I gave you a fraction and I asked you what's a reciprocal, all you'd have to do is take the numerator and write it as a denominator, and the denominator and write it as a numerator, and now those two would be reciprocals. My question to you is, what's the reciprocal of 7? what would the reciprocal of 7 be? And just think about that for a minute. I know I'm not here with you, but just pretend I'm here with you and think about it like you would in class. When you have to give me a reciprocal of something, didn't we just say that you would switch around the numerator and the denominator? Well, the problem with looking at 7 is it doesn't have a numerator and denominator. It's just 7, right? But could you write 7 as a fraction that has a numerator and a denominator? Yeah. We could write this 7 as 7 over 1, couldn't we? That means the reciprocal of 7 would be 1/7. So if you have a whole number and you're trying to find the reciprocal of it, write that whole number as a fraction by putting a 1 under it, and then you can write the denominator as the numerator and the numerator as the denominator. Same idea, what would the reciprocal of 1/8 be? Well, if I write this 8 in the numerator spot and this 1 in the denominator spot, it would be 8 over 1. But is that simplest form? No. So you can say the reciprocal of 1/8 is 8. And there's a reason I'm telling you this, okay? Here, instead of dividing by 8, we multiplied by 1/8. And instead of dividing by 7, we use the inverse operation and change this to times 1/7. And instead of dividing by 3, we use the inverse and we multiply by 1/3. What's the relationship between the number that I started off dividing by and switched it to and multiplied by? If you said they are reciprocals of one another, you are correct. If I put a 1 underneath this 8 over 1, the reciprocal of 8 over 1 is 1/8. The reciprocal of 7 is 1/7. The reciprocal of 3 is 1/3. So when we divided this first set of fractions, what we really did was we changed the problem to multiplication by multiplying by the reciprocal of whatever we were going to divide by. So let's look at the next set. And it's a lot to take in, but we're going to keep looking at patterns. Look at your next set. And I want you to do 3 divided by 1/8. So write down 3 divided by 1/8. And for 3 divided by 1/8, we learned in class, this is like, how many 1/8 are there in 3? And so we asked ourselves, well, how many 1/8 are there in 1? Wouldn't there be 8 of them? Because you'd have 1/8, 8 times in each whole. But now you have 3 whole. So you would have to do 3 times 8 in order to figure out how many 1/8 there were in 3. And 3 times 8 would be 24. So 3 divided by 1/8 means you're taking 3 whole and you're chopping it up into 1/8. And I want to know how many 1/8 are there. There's 24. Next one, 5 divided by 1/7. I'm asking you how many 1/7s there are in 5. Well, there's 7 of them in 1 whole. So that would mean in 5, there would be 5 times 7, which would be 35. And if we had 10 divided by 1/3, I'm asking you how many 1/3s are there in 10? Well, there are 3 of them in 1, right? If you took 1 whole and you divided it into thirds, wouldn't there be 3 1/3s in 1? But we don't have just 1, we have 10. So you'd have to take this 3 times 10, or 10 times 3, which is 30. So what I'd like you to do is look at the pattern here. Instead of dividing by 1/8, I took what I started with and I multiplied it by 8. Instead of dividing by 1/7, I multiplied by 7. And instead of dividing by 1/3, I multiplied by 3. What's the reciprocal of 1/8? Isn't the reciprocal of 1/8 8 over 1? Yeah. And isn't 8 over 1 equal to 8? It sure is. So in this set right here, even though these problems look different than what we started with, because here we divided by a whole number, and here we're dividing by a fraction, you're actually using the same exact steps to solve these. You're leaving your first number alone because you can't change what you're dividing up. Okay, you can't change what you start with. But we can use opposite operations to help us solve this. So we multiplied by the reciprocal. We multiplied by the reciprocal. We multiplied by the reciprocal. That was the same thing we did up here. All right, let's try one last set here of problems. We learned how to take a unit fraction and divide that by a whole number. So the first one I want you to write down is 1/3 divided by 8. So I have 1/3 divided by 8. And if we were going to solve this, remember this is saying like we had 1/3 of a cake left over, and you had to share that 1/3 of a cake with 8 people. You don't have to draw this, but I just want to remind you, I know we've drawn a ton of pictures to represent this already. But if I'm saying you have 1/3 divided by 8, that means you're taking this chunk right here and you're sharing this chunk between 8 people. And each person would only get one of these little pieces. So the answer to this division problem is the fraction that would represent this one little piece, which would be 1 out of, it's not 8, it's not 1 out of 8, because in a fraction, the denominator is how many pieces the whole is broken up into. So you'd have to break this whole thing up into eighths, which would mean you'd have 8, 16, 24 pieces. So 1/3 divided by 8 is 1/24. And remember, we saw that we got that by taking 1/3 times 1/8. That's how we got our answer of 1/24. All right, let's try another one like this. Take 1/5 divided by 7. So if you take 1/5 divided by 7, that's the same thing as, you can't change what you start with, 1/5 times, we're cutting this 1/5 up into sevenths. So 1/5 times 1/7. That would mean 1/35 would be your answer. And the third one in this set, I want you to take 1/10 and divide that by 3. I know I'm using all similar numbers. It's just, I think it's easier to see patterns. So 1/10 divided by 3. I'm going to leave my 1/10 alone, and I'm going to multiply by what? By 1/3, because I'd be taking this 1/10 and cutting that up into thirds. And 1 times 1 is 1, and 10 times 3 is 30. Now I want you to look at what's happening here. Instead of dividing by 8, we multiplied by 1/8. And instead of dividing by 7, we multiplied by 1/7. Instead of dividing by 3, we multiplied by 1/3. So to solve this division problem involving numbers that don't come out to nice, pretty whole numbers, we multiplied by the reciprocal of whatever we were supposed to divide by and got the answer. That's the strategy you use for every single division problem. Okay, it actually works for whole numbers too. It really does. I know, you might not believe me, so I'm going to show you. I do want you to write this one down. I've used the example, and I'll draw my little squiggly line, of 12 divided by 4. And we know that 12 divided by 4 is 3, right? 4, 8, 12. I can count up by 4 3 times to get to 12, or I know that 4 times 3 is 12. What I'm telling you is that for every single division problem you solve, instead of using division, you can use the inverse operation. It's like those little math mountains you have. So instead of doing 12 divided by 4 equals 3, you could do 12 times the reciprocal of 4. Because if we're going to use inverse operations, I need to use the inverse of 4. Remember that 4 really means 4 over 1, right? So that would mean that the reciprocal of 4 would be 1/4, because you switch them around, right? So 12 times 1/4, if this method works, should give me 3. And does it? Well, if I put the 1 underneath here, and you could cross simplify if you want, and change that to a 1 and change that to a 3, or you could say 12 times 1 is 12, 1 times 4 is 4, and 12 divided by 4 is 3. So when we are changing these division problems into multiplication problems, we're not changing what the problem is. We're just changing what it looks like so that we can solve amounts that don't come out to nice, pretty whole numbers. So whenever you are dividing fractions, I mean, if you wanted to change all your regular division problems, you could. It's going to work. All you have to do to solve it is multiply by the reciprocal of whatever you were dividing by. Sometimes the pattern that I see a lot of people that change the number you start with. And I want you to think about this. If I had like a bag of 30 Jolly Ranchers and I was going to share those with the class. Let's say I was going to share my 30 Jolly Ranchers with 10 kids in class. I would start off with the 30 Jolly Ranchers and divide that by 3, right? Can I change how many Jolly Ranchers I have? No. So in these division problems, we never change the first number around because that's what we're dividing up. That's what we start with. What we're doing is we're multiplying by the reciprocal to solve it instead. So we're just changing the operation, and the number that follows, you can't change what you start with. All right, so here's what I want you to do, whether you have to use the back side of your paper or what. I want you to just try a couple examples, okay? So either on the same page you're at or on the next sheet in your spiral, I'm gonna write down a problem and I want you to solve that problem and then press play. So you're gonna pause it and then press play once you have it. So the first one I'd like you to do is, I'm gonna write number 1 here, and you're doing this in your spiral. 5 divided by 8. Go ahead and solve that. Write me the multiplication problem for it and then solve it. All right, so 5 divided by 8. Instead of doing 5 divided by 8, I can keep my 5 because I can't change what I start with, and multiply by the reciprocal of 8, which is 1 over 8, because I could write that as 8 over 1. And 5 times 1/8 would be 5/8. So you should have 5/8 for that first one. All right, number 2, I want you to write in your spiral 1/5 divided by 6. And you can look at the examples on your notes to help you out with this. Press play when you're done. Okay, so in order to solve this problem, because I know it doesn't come out to a whole number, and I can't ask myself, well, 6 times what is 1/5? That would be pretty tricky to think about, right? So I'm gonna keep my 1/5 alone. I'm gonna leave it alone. And I'm gonna multiply this by the reciprocal of 6. So right now I could write 6 as 6 over 1. The reciprocal of 6 is 1/6. That would mean I would have 1/30. And if you think about it, if I take 1/5 divided by 6, that means I'm only taking like 1/5 of the pizza. That's all I have, and dividing that up into 6 pieces. So each of those pieces would be a 1/6 of it. All right, number 3. Again, I told you there's six of them total. 7 divided by 1/4. So I'm asking you how many 1/4s there are in 7. Try this on your own and press play when you're done. 7 divided by 1/4 is the same thing as 7 times the reciprocal of 1/4. The reciprocal of 1/4 would be 4 over 1, right? And 4 over 1 is equal to 4. So the answer would be 28. And think about it, I'm asking you how many 1/4s there are in 7. Well, there's 4 in 1, right? There's 4 1/4s in 1. So there would be 4 times 7 in 7. Right, number 4, do 9 divided by 10. And press play when you're done. 9 divided by 10, I can change to 9 times 1/10, because the reciprocal of 10 is 1/10. And if I have 1/10 9 times, I have 9/10. Okay, number 5, do 1/8 divided by 9. And press play when you're set. All right, so if you have 1/8 of something and we divide it by 9, that means 1/8 times 1/9 is what we're doing. So I would get 1 over 72. And think about that. You only have 1/8 of something, and then you're taking that little tiny 1/8 and cutting it up into 9 pieces. We're going to get something that's a lot smaller than what we start with. Right, here's your grand finale problem. 12 divided by 1/3. So I want to know how many 1/3s there are in 12. To figure that out, I can leave my 12 alone and multiply that by the reciprocal of 1/3. The reciprocal of 1/3 would be 3 over 1, or just 3. So there are 36 1/3s in 12. This is it for math today. I just wanted to make sure you had everything down pat, and we'll continue to review this. So if you're feeling like, I don't know, Mrs. Tremblay, I'm not quite there yet, we're gonna review this again on Monday, and we'll get you where you need to be. Thank you so much for working so hard and for watching. I hope you have a fantastic weekend.